Good afternoon, everyone. Hope all is well. Hope everyone's doing
Good
all right.
afternoon.
Hey,
Yep,
hey, hey. How's it going?
pretty good.
All right. Well, as always, give everybody a few seconds to get in, and then we'll get rolling.
Professor.
Yes.
So for the past week, I've been trying to get on and use Math Lab, but every single time I try to open up the class, it keeps saying your content has been opened in a new Windows browser, and then I'll go open on my browser and it's not there, so it won't let me access the work because it keeps saying it opens in another browser.
Are you using Safari?
Yes.
Maybe that's what it is. Try using Chrome. MathLab
Okay.
doesn't interact well with Safari. Maybe that's what it is. But you are
Okay.
going to mathlab.com, right?
Yes.
Yeah, so it got to be the Safari piece. So try using Chrome and let me know what
It,
happened.
it would be Pearson. Yeah, Pearson.
Yeah, yeah. You can
Okay.
go to either type in www.mymathlab.com or if you go through the Pearson, they got another long one for it. But either way, it'll take you to the same page.
Okay.
I had the same exact issue, and I had to download the Chrome browser to get it to work.
Hold on, I didn't hear nothing you just said because you cut Lamont. Well, hold on one second, Mr. James. So Lamont, you good? Want to make sure.
Yes, I'm trying on Chrome now.
Okay, all right, cool. All right, so Mr. James, you said what were you saying now?
I was saying I had the exact same problem, and to
Okay.
fix it, I had to download the Chrome browser.
Okay, cool. Thank you. So you confirming what Lamont was going through. Thank you. Appreciate that. So yep. So
That
all right.
happened to me too, but I still use Safari. It's just in the search bar. It's going to be like a little pop-up symbol, and you click that pop-up symbol, and then the page is going to open up.
Okay. Well, you're lucky because I had plenty of people, and I think even Pearson said that sometimes don't interact well. So it must be a sometime thing, just depending on I guess you're playing probability and stats on it, on whether it's gonna work or whether it's not gonna work. So that's cool that it worked for you. I think you're like the first person that actually told me that Safari. You found a way to make it work with Safari. So that's cool. That's cool. All right. Anything else? Anybody else before we get rolling? Make sure everybody's good. I know we did 10-2, 10-3. I don't think we did 10-4, solving percent proportions. No, hold on. I think we did do that. Let me go back. Let me go to 10-4. 1-1, 7-1. We did that. Percent proportions applications. Okay, no, this is where we at now. Solving percent proportions. All right. Where's my pen? So this is 10-4 for you guys, percent proportions. All right. So when we look at proportions or setting our percents up as a proportion, this is how we're going to do so, this red box. We're going to set our percent over 100. And then you can think about it as equal to is over of. And so you'll see what I mean in a second. But the is going to be the amount or the part. And then the of is going to be base or the whole. So you'll see what I mean when we get down to this number in a second. But that's the best way to do it. But the easiest way for me is whatever name or whatever number is attached to is, that's going to go on top. Whatever number is attached to of is going to go on bottom. And then your percent number will always be placed over 100. So that's what this setup means. Give me a chance to write before we get there. All right, so let's look at this first one. What is 30% of 180? So no words wasted. Notice that what is attached to is, then we have 30%, then of 100. And so that's what I mean. Whatever something is going to be attached to is, something is going to be attached to of, and then you have your percentage. So your 30% is right here, 30 over 100. Whatever number is attached to your percent is going to go over 100. Then it says what is. What is our variable? So is going to be X, and then of 100, that'll be the bottom number, which is 180. I say of 100, of 180, excuse me. That'll be your bottom number. So that's what I have here, is over of. All right. So before we go to solving, is everybody okay with the setup?
Oh, I thought EOS, you say EOS is the 100. Oh, I thought,
No, percent is 100.
okay, the percent is
The
100.
percent number.
Percent
Because
is
remember,
100.
we talked about
Right,
last
okay.
class, 1%. I mean, the percent symbols represents 1 over 100. So whatever number is attached to the percent sign will always be that number over 100. And notice how now it splits up the problem or splits up your sentence. This is what is, and then over here of 180. So the is, whatever is attached to is goes on the top number, which is right here. And then whatever is attached to of goes on bottom, which is down here at 180. All right, questions on it? Everybody good on the setup? So now we talked about this last class with solving proportions. From that point, once you have your proportion, we have our proportion set up. Now we can cross multiply. That'll be 180 times 30, 100 times X, 5,400 equal to 100X divided by 100. And X is equal to 54. All right, questions before we look at another one? This right here is just reemphasizing what I just wrote up there. I think somebody had a question. I was just reemphasizing that is that top number is also called the amount, which is also called the part. Like I said, I just wrote that up here, but probably was just laying it out. Somebody else had another question. Bottom number is your base, or sometimes called a whole or total. So like I said, you don't have to rewrite that. I just talked about that up there. All right. So here we have 40% of what number is 25. So once again, break up your question accordingly. 40% is right here. That's going to be 40 over 100. Then it says of what? So of is going to be the bottom number. That's going to be your variable because it's saying what. And then is 25. And that'll be your top number. Questions, make sure we're good.
So your bottom number over here is going to be 100 then.
Right here.
No, with the exit under 25.
Oh, we got to solve.
Okay, I'm sorry. I'm sorry.
Yeah, we got to cross multiply to find out what it's going to be.
Okay, thank you.
Yep. But initially it's X because we have what of what. So initially it's going to be your variable. Right? So now when you cross multiply 40 times X, then 100 times 25 on the other side. That's 40X equal to 2,500 divided by 40, 62.5. All right. Questions. All right, can I scroll up? All right. So 12.4 miles is what percent of 80 miles? So once again, we're breaking it up into is over of and the percent over 100. So 12.4 is. So that's my top number of my fraction. Then it says what percent. So this time my percentage is unknown. So that's why I have X over 100. Whatever is attached to a percent will always go over 100. All right. And then from there of 80. So of is my bottom number for my other fraction. All right. Everybody good? All right, so from there, cross multiply. X times 80, 100 times 12.4. $80 times X, 100 times 12.4. 15.5 when you divide both sides by 80.
So, Professor,
Mm-hmm.
okay, remind me with the decimal again. Because I noticed when you put the 1240 over 80, you didn't put the decimal there. So remind me how I know where my decimal go again.
Now, hold on now. Where you said, oh, you talking when I did that?
Yes, but you know that the answer has a decimal in it.
Yeah.
So remind me about my decimal, how the decimal works.
Oh, you don't want to just use a calculator, huh? We keep coming back here.
Well, see, I'm not doing it now with the calculator. So, okay, so I was using my calculator, it would give me.
So you talk about going from here to 15.5, right?
Yeah.
So that means you're just talking about doing long division. So 80 doesn't go into 1, it doesn't go into 12, but it goes into 124. 1 times 80. And then that'll be what? 440.
400.
I just wanted the basic rule, so I just moved my decimal 2 times to the left.
Well,
To
this
the
is
right.
this gets to the rule because what's going to end up happening is that you're going to have something right here. You're going to have a remainder. You're going to have to add a 0, and then that decimal comes up there. And then
But if I don't do it, I know to add my. I just move my decimal 2 points to the right.
Now when you dividing, or are you talking about multiplying? Now, if you're talking about multiplying,
no,
from here to here. Now, dividing, what dictates whether you move that you have a decimal or not is the fact that you decide to go past this remainder and add a 0 right here.
Okay.
See what I mean? So that will dictate that. Moving it to the right is when you multiply.
Okay,
Mhm.
okay. So the best thing for me to do is use my calculator.
Yeah, if you're not comfortable, with that, then especially since that's not the emphasis of this practice, it's best to just go ahead and throw it in the calculator. It'd be different if that was the emphasis and we were talking about dividing and multiplying with decimals to making sure that that foundation is straight. Like I said, at this point, they're assuming that you already good with it. So they're not really emphasizing it. So using the calculator would not be an error. They don't mind it at this point.
Okay, thank you,
Yeah.
sir.
Yeah, not a problem. Now, if you do want to, make sure your foundation is straight, we can either set up the office hours or we can set up a time where we can meet and we can walk through it sometime, a few times to make sure you're good and have a full understanding. I mean, I don't mind doing that at all.
Please.
Hmm?
I say, please.
Wait, no, so you end up either come to my office hours or shoot me an email to set up a time. You see what I'm saying? So
Okay.
whether it be office hours or setting up an email so we can meet individually or take out that time to talk about long division, then that'd be on y'all when y'all shoot that email to me. Or like I
I'll
said,
set
just
up
come
an
to an office
email.
hour and we'll make it happen.
Okay. Thank you.
Yep. Hold on before we do this. Yeah, okay. I think you may see one or two problems like this. Are we done with that last one before I go to this last one up here? Okay. So in a recent year, the freshman class of a university had 18% Asian American students. So I kind of shortened it up, American. If this represented 380 students, how many students were admitted into the freshman class? So round to the nearest student. So give you a chance to write that down and then we'll look at breaking it down. All right, so when we look at what we have here, it's always good to pull out the given information first. We see our percentage here that represents 18 Asian American students of the total population of freshmen. And that is 380 of them. That 18% represent the 380 Asian American students. So then ask you how many were admitted to the freshman class altogether. So here's our setup. The 18% goes over 100. So 18 over 100, remember your percentage. You got, if you hold true to that, you already know part of your proportion. Percentage always go over 100. Then from that point is over of, or in other words, part over whole. Remember I told you that that your is the part or the amount, and then the bottom of your of is your whole or the total. So this 380 represents part of the total freshman body. So that's why it's 380 over the X, because that's what we want to know, how many total freshmen were admitted. So that's why we got the same setup, just got to be able to parse out the part versus the whole, or part versus the total. Questions before we go ahead and finish up? Sorry, when your classmates email them, I think they're trying to get into the class, so I'm trying to help that person out. All right, so we have 18 over 100 equal to 380, excuse me, over X. And once you have your proportion set up, now you can just cross multiply like you would any other time. And so that's what we did here. X goes to 18, 100 goes to 380. So that's 38,018X on one side, divide by the 18. And then you have 2111.11. And then it said also round to the nearest student. So always make sure you pay attention to the directions on rounding, whether they want tenths, hundreds, or whole number, whatever the case may be. So we round to the nearest student, that's going to be 2111.
I'm getting lost at. So you put the decimal behind the fourth number. Just
Mhm. Now look, let me go back. If you're going back to the decimal, you're not going to understand it until you do this. So it's not something right now, nothing magic is happening here, except I put it in the calculator. You see what I'm saying? If you want to know where the decimal goes, you have to go through the long division process. Other than that, it's not going to make sense. I'm just shooting breeze. We just shooting the breeze until you walk through the long division process, and then that'll
Okay.
place the decimal right there. So it's not even like a real trick to like where are you placing the decimal or how do you know how to place the decimal, except for walking it out through the long division process. And then as you go through it step by step, you'll get to this point right here and you'll place the decimal right here. And that's what dictates where the decimal will go. And that's why I said for that question is more so we need to sit down and walk through the long division process so you'll understand, what I'm saying? Because that's more than just moving the decimal to the right or left. That's actually walking through the process. And then the process will dictate where that decimal goes in your answer. So, yep, no problem. So like I said, just shoot me that email so we can make that happen and make sure you have understanding. So all right. Everybody good with this before we go to the next section? So that's what this section was about, setting up your percentage problems as proportions. All right, so everybody good? Everybody good? Okay, so let's look at percentage problems using equations. Same keywords, but we're going to set them up as equations. Now, it does not matter which process you use, proportions versus percentage. So that was 10-4, 10-4. Okay. So it doesn't matter, both of them are 10-4. So it doesn't matter which process you use, whether it be proportions or percent or equations. It's same keywords, you're just setting it up different way. Unless MATLAB say what is the equation for this or what is the proportion. Unless they say it like that, then you have to set it up this way. But either way, you'll get the same answer if you do it correctly. So here are keywords and how they will represent, what symbols they will represent in an equation. Is always your equal sign. Percentage is your decimal. Remember we talked about going from percentage to decimal, moving 2 places to the left. Of is multiplication. In mathematics, of always represents multiplication. And then once again, what is your variable? So we have 18 is 21% of what? So if we just translate that to an equation, 18 is 18, just bring that down.
1 second, sir, don't move it, please.
Okay, did I need to scroll up or this is good?
going to snap a picture. Hold up.
Okay.
18.
Okay, so 18 is 18. Like I just mentioned, is the equal sign. So notice that translates to equal sign. 21%, we talked about last class, how you convert a decimal to a percent to a decimal by moving your decimal 2 places to the left. So we converted that 21% to 0.21 of is multiplication. What is X? So when it comes to setting up your percentage problem, whether you use a proportion or an equation, that will be based on preference. You might see an equation and say, I like to do this better. You might like your proportions better. It's up to you. But once again, they will still give you the same answer. All right, can we scroll up? Everybody, y'all let me know.
Professor,
Yes, ma'am.
I just wanted to tell you, I just love the way you break it down. I tell you, make it so much clearer.
Okay, cool. I appreciate it. I'm glad, 'cause, when you
I
say
like
stuff like that.
your teaching. Your
A
teaching
great job.
tactics. Yes.
He's oh, appreciate it. Appreciate it. Like I said, when you tell me like that, let me know I'm doing it all right. And I can keep on moving in the same direction. But I know
You
what
do
you're
it so
doing.
simple. You
I,
do
I
it so
You're a
simple.
little slow now. We
look,
may be a little slow getting it, but it ain't because you ain't doing a great job.
look, I already know what she's doing, y'all. She's trying to posture herself to at least get that B out of the course. So
No. Oh, I'm gonna get a B call. You breaking it down for me. You preparing me to get there. So
What I say,
yeah.
I'm slow, but you doing it.
Hey, that's right.
I appreciate it. I appreciate it. So once you set it up this way, then now that means is that that's 18 equal to 0.21x. And now all you have to do is solve or divide both sides by whatever's attached to x, because you want to get x by itself. So whatever's attached to x, divide both sides by that, and which was 0.21 for us in this case, and that'll give us 85.71. Once again, Math Lab will let you know how many decimal places they want. Yep. Let me see, how many sections do we have in chapter 10? So any questions before we try it again? Make sure we're okay.
Just try it again.
All right. So here we go.
Okay, that's the next one, right?
Yep. What is 79% of 80? So once again, just take your time, match up the symbols with match up the words with the proper symbols. What is always your variable? That's x. Is your equal sign. 79%. We're going to move our decimal 2 places to the left to give us 0.79. Of is multiplication, and then 80 is just 80. So now notice what we have here. X is already solved for. X is already on one side by itself. So all you do is just multiply 0.79 and 80 together, and that'll give us 63.2. So, just make sure you take inventory of the difference between this one and the last one. The last one had X attached to a number, so we had to solve for X. This one, we didn't have to because X is already on one side by itself. So all you have to do is multiply these two numbers together, and that'll be your answer. So X is equal to 63.2.
Oh, okay. So you multiplied this and this.
Yep, these two
Okay,
numbers.
okay. I get it. Thank you.
No problem. And I threw it in the calculator. Ms. Glover, I threw it in the calculator. I just want to go and throw that out there. Any questions before we look at another one? All right. I think we got another one down here. Yeah. All right. New one, $26 is what percent of 40? All right. So once again, matching up numbers and words. So that's 26 equal to X times 40. So the X and the 40 are on the same side. So that's 26 equal to 40X. Divide both sides by 40. Because we want to get X by itself. And that'll give us 0.65 or 65%. Make sure you watch how MathLab asks you for this answer. So when you divide 26 by 40, you're going to get 0.65. But if they want the answer in percent form, got to convert it by multiplying, move your decimal 2 places to the right. So they could ask for it like this. They may have a box and have a percent on the outside, and you'll put 65 in the box. But whatever way they ask for it, just make sure you're paying attention to the directions. Either one of these answers are fine, either 0.65 or 65%. And like I said, MathLab will let you know which one of those answers that it actually wants. And they could switch from problem to problem, so you got to pay attention to the directions. Everybody good? Questions? All right. Here go another one. 180% of 20 is what? So 180% converted to a decimal by moving your decimal 2 places to the left. That gives me 1.8 of its multiplication. 20 is 20. Is equal. What is your variable? And once again, we have a scenario in which we don't have to solve because x is on one side by itself. So all we do is multiply 1.8 times 20, and that's 36. All right, questions.
I know this is gonna sound dumb, but can I ask you this question? In one of them, you multiply, and one of them, did you divide?
Yeah, it depends on the positioning of your x. So notice here, x is on one side by itself. So all I need to do is just calculate whatever's on the left side. So that's multiplication.
Okay.
So now if I go back here, notice x is over here with 40.
Okay.
So I need to get x by itself. That's always your goal, to get x by itself. So if x is not by itself, I need to do whatever it takes to get x by itself. So when I simplify that equation, I have 26 equal to 40x. So I need to get rid of this 40 because I just want x. So that means I'm going to divide both sides by 40. So that's what would cause you to divide. If there's something attached to your x and you need to get it off of x. All right. So does that make sense? Or I need to say it a different way? Is that okay?
I saw what you did now. I just say I must have saw something.
Okay, cool. All right. Anything else? Anybody else before we we got some more time. Yes.
When you have the dollar signs there and our answer was supposed to be a dollar sign?
Well, in this case, it was percent, so we didn't have to do it. MathLab will let you know. MathLab will let you know. I think that if it was a measurement, like whether it be dollar sign, miles, or whatever, I think you can just put in the number and be okay. This one didn't have it. Let me see the last one. It was one that had miles. It must have been on the other sheet. But MathLab will let you know. And if you ever get it marked wrong just because you didn't type in the measurement, I don't think they will do it. Just let me know. No big deal. We can adjust that. It's not a big deal.
Okay.
All right. Anything else? Anybody else? Everybody good? All right. So let's look at what's going on here. Which section? So that's 10.7, 10.6. Yep. So it skips 10.5 and goes to 10.6. Applications of percent. So, that's okay. This stuff's short. Okay. Yep. Come on. All right. So let's look at 10.6. So we have Frank, who earns $41,400 one year and receives 5%. If he receives a 5% raise in salary, what is his new salary? Give you a few seconds to write that down, then we'll look into it. All right. So when you're talking about getting a raise, I'm pretty sure you guys can calculate this without my help at all, because y'all are about y'all money. But if you want to talk about putting it in an equation, the equation would involve three pieces, and that's what we have here in red. You have your original pay, the raise, and now your new pay. And you're going to add the raise to that original pay in order to get the new pay. The new pay cannot exist without the original and then the raise part and adding them together, right? So in order to calculate the raise, this person is going to receive 5% in raise. Well, that 5% is not just 41,400 plus 5%. It's 5% of your original pay. So don't forget, we already talked about of means multiplication in mathematics. So if you're talking about 5% of original pay, that's 5% times 41,400. All right. And so if we just go ahead and do the calculation, that 0.05, remember 5%, if you're going to calculate with it, you have to convert it to a decimal first. So you move your decimal 2 places to the right. So 5% converts to 0.05. Multiply that times the 41,400, and that's how you get the 2070. Once you have that 2070, you add it to the 41,400, and that'll give you 43,470.
Got a $2,000 increase.
Not good enough for you, ma'am? Sounds like you were expecting more.
No, I didn't. I'm glad.
Any questions? Any questions? Everybody okay with what Frank got before we scroll up?
One second. I'm writing 1 second.
Yeah, no problem. No problem. No problem at all. So this is 10, 7, 10, 8. So I think we
Frank income
will.
right now.
Okay, I got it.
Okay, sounds good. Sounds good. So let's look at the next one. And I'm just showing you different ways that you can do these percent problems. You may see another way, and it's perfectly fine. We're just showing you different ways to solve these type of problems. So we have an office building that has 50 offices and that are currently being rented. This represents 40% of the total units. How many offices are there in the building? So, you could use the equation setup that we talked about before, or the proportion setup that we talked about before. We talk about part over whole or base over amount. I think I did equation. I might have did both of them, but we'll see. Give you guys a chance to write this out first. Excuse me. Okay. So another way of setting up these equations is PBA. P times B equal to A. So the percent times base equal to the amount. So the percent times the whole, we said the base, and I wrote it right here, the base is the total. Percent times the total is equal to the amount. That even goes back to when I said percentage, 5% of his original pay. So if you want to know what 5% of the original pay is, you take 5% times the total of the whole amount, to get that part. So when we look at what we have here, your percentage is always the easiest one to pick out. That's the one attached to the percent sign. But it says percentage of the total units. So the total units is what we don't know. It says how many offices are there in the building. We don't know that. So that's going to be X. B is going to be X. And then the amount rented is 50. So 50 out of the total number of units in the building is rented. Okay. So if we're talking about how we would set it up, like I just mentioned, PBA, P times B is equal to A. Take your percentage, which is 0.4, times your base, which is X. We didn't know the total amount of units. That's equal to the part or the amount, which is 50. The part we didn't know was the total number of offices. All right. If I were to use the equation format that we talked about before, is and of and all that, or if I were to use the proportion, it would still set us up this way. X would be multiplied by 0.4, and then 50 would be on one side by itself. So then we divide both sides by 0.4, and that will give us 125 total offices in that building, or office units in that building. All right, everybody good? Before we scroll up. Straight. All right. An Olympic team consists of 145 members. Approximately 43.2% of the athletes are men. How many men are on the team? All right. So as always, you want to look at your problem and then pick out or extract all the given information. We have 43.2%. So that's, like I said, the percentage is always the easiest one to pick out because it's attached to the percent sign, or you see the word percent somewhere. So 43.2%, convert that to a decimal, move the decimal 2 places to the left is 0.432. Then it says the whole team has 145 members. How many men are on the team? So the number of men is the part. So the whole team is your base. That's 145. And then the amount of men that we're looking for is X. All right. So now we set it up. Like I said, if we're going to use the PBA, our percentage times your base equal to your amount. So it's 0.432 times 145 equal to X. And X is on one side by itself. So it's one of those situations where we don't have to solve. we can just go ahead and multiply because we already have x on one side by itself. Oh, hold on. All right, we're good. And so multiplying the two numbers on the left gives me 62.64. And notice I said round to the nearest whole number because there's no such thing as 0.64 of a person. So this would be one of those situations where they would expect you to round to the nearest whole number. So it'd be 63 men. All right. Everybody good? Everybody straight? Any questions before I go to the next thing? All right. So we got, say again now?
Oh, I just say thank you for asking.
Oh yeah, no problem, no problem. I'm checking these, see how long, got 10-7, 10-8 is left. Okay, so not too bad. So I am going to pause right here. This is a good place to stop because we only have 2 more sections left out of chapter 10. I told you I was gonna try to pace this thing out. If I wanted to, I probably can knock out chapter 10 in one day, if one sitting, if we're not careful. So trying to pace this thing out. We have 2 more sections left out of chapter 10. That's 10-7 and 10-8. And we'll do those on next class. And then we'll talk about how we're going to move forward and what due dates, we want to set up and establish and everything like that, because we'll be officially done with chapter 10's content. So before we close out today, any questions, concerns, comments? Everybody good? Anybody? Straight. So, make sure you're getting into math lab. Make sure you're not, taking for granted that these due dates, give you enough time, because you don't want the stuff just lingering out there when you could be knocking stuff out regularly and everything like that. And but if due dates get on you and you need an extension, don't just take zeros. Shoot me that email, ask for extensions or whatever the case may be, so we can make sure you have the opportunity to get the grade that you desire out of the course. I heard somebody unmute.
No, I just was gonna say bye.
Oh, okay.
Finish.
All right. You have a good one. Take care. And
Okay. See you.
I'll see you guys on Wednesday.
All right, see you later.
Thank you. Take care.